There is a holiday this week, so we don't have class on Thursday and we don't have an office hour on Friday. Campus is closed on both of those days. There's a homework due tonight. It's homework number 10. Okay, Thursday, Friday, no quiz this week, mostly because I need to finish grading your exam, number 2, but also there's a holiday, might just as well skip the quiz. But we probably need to do one next week to help the quiz grade. And then homework 11 is due on the 30th, next week on Tuesday. And there should be only 12 homeworks, so we're almost done with all of our topics, and then we'll start getting ready for the final exam in a few weeks. Oops. All right, so we're doing notes for homework 11. I have to go through the notes sort of quickly since we're only meeting once this week due to the holiday. We want to talk about using the square root property, completing the square, and functions, which we don't have a lot of time to do, but I'm going to do my best. Okay, for the square root property, you have a variable, and then when you square root both sides, you can have the plus or minus of the square root of a number. So I want to point out the difference between the square root of a number being simplified and using the square root property. Okay, first of all, let's talk about square rooting a number. So we've already done this part before. Okay, if all you have is the square root of the number 9, and that's it, the answer is positive 3. Okay. Then you're looking at this other number, and it's the square root of 25. You can simplify this to positive 5. One more. So the square root of 4. The answer is, or simplifies to, positive 2. Okay, this is something sort of different. It's not just a number, it's an equation. So what you're given is, let's do x squared equals 9. Okay, so let's say you're asked to solve for x when you have x squared equal to 9. When there's a variable x, you'll have 2 answers. X could be 3. But if I want to put in negative 3 for x, I could have that negative 3 squared, and that equals 9 as well. So you could get 2 answers. Negative 3 or positive 3. Okay, so for equations that look kind of like this, you can use the square root property. Google, it said the square root method. Okay, so this can be used to solve equations of the form. So you have some set up like this. And x is a variable, b is a number. That variable is squared. So we can square root both sides and get a negative answer and a positive answer. Or you know what? We're going to just say it depends on the problem. So you may get two answers. So this will be positive or negative square root of b, and then you continue to solve for x. You'll have two answers in the end. Two solutions. Okay, so solve, or you could say solve for x. Put a little bit extra. And you have x squared equals 25. Okay, so I would just copy this down. Take your equation. Use this method to square root both sides. The square root will undo that power of 2. So that will leave just x, which we're kind of, that's our goal, is to solve for x and isolate it. So that root 2 matches that power 2, but I need to do the same thing to both sides of my equation. And root this side. And since I have a variable x, I want to put a plus or minus before this root. So plus or minus root 25. Okay, so from here we have x equal to positive or negative of the root of 25, which, like I've mentioned before, just this number, root 25, is 5. And then you have a positive or negative before. Okay, so what this means is x is positive 5 or x is negative 5. Okay, similar but different question. Let's have x squared equal to Okay, so I've written the problem down, but I've written 100 as 10 squared. And then when I square root both sides, in this case, like I want to root this side to get rid of that power on x. Like if it were a cubed root on x, I would cube root both sides. But we're going to stick with the square root here and here. And then on the number, we'll have a plus or minus before the root. Okay, so this root undoes that power of 2, and you have x on this side. Here there's a plus or minus. And again, this power 2 with that root 2 leaves 10. So x is positive 10 or x is negative 10. This time we have x squared equal to, let's do 5/4. So here I'm going to start scratch work and just copy this problem down. To get rid of that power of 2 on x, because I'm trying to solve for x, I would square root. And you need to do the same thing on both sides of your equation. And with the square root property, you're going to put a plus or minus in front of the root. Okay. Square root of x squared is x, equal to positive or negative of the root of 5/4, which we're going to use the rule for radicals and division. So we can have the root of 5 over the root of 4. Oops. Okay, and then let's simplify the square root of 4. Square root of 4 is going to be 2. So plus or minus root 5 over 2. Okay, so we're here with x equal to a positive or negative root 5. And your two solutions are the negative of root 5 over 2. Okay, another one using the square root property. And we're going to just keep solving. Let's solve for t. So solve for the variable t. Seven t minus 3 squared equals 36. So just copy this. Just how it is. Okay. I'm trying to get this T isolated. So I need everything around it to kind of get on one side of the equation, following all of the appropriate rules. Okay. First is to get rid of this power. I can take care of this power 2 with a square root, or root 2. So we square root this side, but this is equal to this, so the root of this number has to be equal to the root of that number. When there's a variable in the equation, like this variable t, on the number value, I would put a plus or minus in front of the root. Okay, so this power 2 and the root 2 leaves 7t minus 3. And equal sign, the plus or minus, and then the root of 36 is 6. Okay, so I have 2 equations to work on. Usually, if I had scratch paper, I would do them side by side, but we'll do one and then the other. And I only need to get those 2 solutions for t. Okay, so either 7t minus 3 is equal to negative 6. Maybe we'll split this. Well, let's just finish. Okay, solve for t. We have 7t equal to negative 3. Means t would be equal to negative 3 divided by 7. And so is this equal to the positive of 6? No, negative of 6. Now we do the positive of 6. We need 7t minus 3 equal to positive 6. And then the second equation, get that other solution for t. Okay, divide both sides by 7. So we got negative 3/7 and a positive 9/7. For my 2 solutions for that variable t. I think there's time for another one of these, and then we're going to talk about completing the square. Okay, so we're going to solve for a. It's 3a plus 1 squared. Okay, scratch work. I just copy this down to get started. Okay, So I want this A all by itself on one side of the equation, use the rules we've talked about this semester to have everything else on the other side. Let's start with taking care of the power 2. So match that power 2 with a root 2. You square root this side, you're going to square root that side and have a plus or minus sign. Okay, so with the power 2 and the root 2, what's left is 3a plus 1. And then it's a plus or minus the root of 9, which is 3. So 2 equations out of this. 3a plus 1 equal to the positive of 3. 3a plus 1 equal to a negative of 3. Let's start with the negative. 3a plus 1 equal to negative 3. And then solve for a. So we need to subtract 1 from each side. Here you have 3a is equal to negative 4. Let's divide both sides by 3. Get a equal to negative 4. Okay, we need another equation. The one with 3a plus 1 equal to negative 3. Okay, then we solve this for a and we're done. 3 a equal to negative 4/3. Wait, just did the same thing, didn't I? We need a positive 3. Okay, we need 2 solutions. We need this one where you have 2 thirds. So we need to divide both sides by 3. A is 2/3. Okay, so that's going to help with the first 5 or 6 problems of your homework. Then you have to work on completing the square. So I have general steps of how to solve an equation completing the square, but also we're going to use just fill in the blank to practice how to just complete the square on an, I think it's called a quadratic. Okay, completing the square. Okay, good. So part of what this explains is just plain completing the square, but I'm gonna go a little bit bigger and past that and explain how to use completing the square to solve an equation. Steps for solving equations. By completing let's see. I'm going to put / complete the square. And then just as a side note, when I was first taught how to complete the square, it was mostly by memorizing a couple of steps, and it was a bit stressful at the time. But after talking with students, I've been shown how to draw a square and then complete an actual picture of a square. And it's much, it may take a little time, but it's less stressful, it's less memorization of the steps that you need to do. And we're going to practice, of course. But first, step. You want to take the equation and write it in this form. So write equation in the form. Where you have the x squared and plus bx. So your variable squared plus some number times the variable. You need this piece to start with, and then have everything else on the other side. So put the number over here. We're going to call that number C. So this little piece you do need to memorize. It's not that bad. It's part 2. You add whatever variable is on with x, which in this case is b. You add b, but it also needs to be divided by 2 and the whole thing squared. So again, you might want to memorize this part for the future. If for some reason, like, in statistics, let's say you take stats, sometimes you do need to complete the square in some of those problems. So you do need to know this little piece. Okay, we'll practice soon. Number 3. Oh, add this, by the way, if it's an equation, you need to add it to both sides of the equation. Okay. On the left side, you'll have x squared plus bx plus b over 2 squared, this number that you just added. And on that part, you can complete the square. So what we'll be able to do is take this and write it as some factor squared. So that's like part of the name completing the square, is write this as some value squared. Or I like to also think about the picture I'm going to draw, which is also a square shape. Okay. And after that, we can square root both sides to solve for x. Okay. Okay, so for the first couple of examples, all I'm going to do is take something that looks like this and factor it. So we're only working on step 3, and it's not solving or anything. It's just taking an expression and working on how to factor that expression. After we do that a couple times, after we know what number 3 means, We'll go through all the steps to solve actual equations and get two solutions. All right, so we want to fill in the blank. Blanks to complete the square. X squared plus 18x plus blank is equal to something, which we're going to figure out. So this is a fill in the blank part. This is a fill in the blank part. And on this value on the outside, it's squared. So going from this form to this form is completing the square, factoring it into some value squared. Okay, so again, if you've memorized how to do this, go ahead and fill in the blanks. I do some scratch work and draw some pictures, and that's how this is a bit less stressful for me to do. All right, start with what I need to add. To complete the square, we add b divided by 2 squared. Okay, what's b? B is whatever number is on x. So take 18, put it in place of b, divide by 2, and then square the whole thing. So right now we have 9 squared, which would be 81. So to complete the square for something where you have the x squared and the number times x plus something, that value is b over 2 squared, which we got as 81. And then to get to the next step, I like to draw a square. It's for multiplication. So what you have in here are the values of this quadratic. So I'm going to put x squared in this corner, put 81 right here, and then start to fill in the sides. So x times x would be x squared. 9 times 9 would be 81. So these numbers multiply to 9x. Same thing right here is a 9x. I want these middle terms to add to positive 18. So I want this to be a positive 9x with a positive 9x. So x squared plus 18x plus 81 would be equal to x plus 9 times x plus 9, or x plus 9 squared. We're done. Okay, the next one is another fill in the blank, or fill in the blanks. x squared minus 6x plus blank would be equal to something squared. So this blank and this blank. I'm going to start with this number. So what you're doing from here to here is completing the square. And the number you have to add to complete the square is b over 2 squared. B is the number with x. So we're taking 18, we're here. Negative 6. Negative 6, divide that by 2, and then squared. All right, so negative 3 squared is 9. So I'm putting a 9 right here. And that way I'll be able to complete the square. And I do this by drawing a square. Maybe you have a different way or you've memorized these steps, but I always got stressed out from the memorization part. So I just put my x squared in this corner, 9 and the other. And start working on the sides. X times x would be x squared. 3 times 3 is 9. And then let's start to fill in these corners with a 3x. 3x, but you add them together to get the middle term. And my middle term is negative 6x. So I want this to be a negative 3 and a negative 3. So this would be negative 3 here and a negative 3 here. Negative 3x. So x squared minus 6x plus 9 factors into x minus 3 times x minus 3, or x minus 3 squared. Okay. We're still going to be able to practice completing the square when we solve equations. So we're going to switch to using all of the steps. So next example is to solve for x. What we're going to do is have x squared plus 4x minus 5 equal to 0. So from the steps that we went over, and also kind of by seeing how we did those fill in the blank problems, what we really need to complete the square are these values, and then we add that special number, b divided by 2 squared. This number is just sort of sitting there. And I think it helps if we, just like the steps mentioned, if we get that value over on the other side of the equation and keep these, the part where you have the x squared and the x, keep these together. Okay, so we've got x squared plus 4x minus 5 equals 0. This is just one way to solve the problem. Get this number over here, have x squared plus 4x equal to 5. Okay, on this part, we could complete the square if we add b over 2 squared. But if I add that number on this side, I have to add it to this side so that both sides stay equal to each other. Anyway, so over on the side or on different scratch paper, b divided by 2 squared. B is that number with x. So take 4, divide by 2 squared. And 2 squared. Is 4. Okay, so we'll take this equation we're working with, and on both sides we're adding 4. Then on this side we can complete the square. And on this side we have the number 9. So I'm going to do that picture of a square to complete the square. So again, maybe on that separate scratch work or on a different, part of your paper. We want to, let's not do that. We want to draw a square. And then we want these terms in the square with x squared in that corner and 4 in the other corner. And you want these corners to add up to that middle term, positive 4x. So get the sides, x times x is x squared. 2 times 2 is 4. This would be 2x. That's 2x. And if you add those together, you would get positive 4, which we do have positive 4. So this needs to be a positive 2. This is a positive 2. And let's see. X squared plus 4x plus 4 is x plus 2 times x plus 2. Or x plus 2 squared. So on the left side, we completed the square. On the right side, we just add. And then you square root both sides. When you square root, we need a plus or minus of that root. So here you have a power 2 and a root 2. So what's left is x plus 2. Part in the parentheses, equal to plus or minus. All right, and now we have 2 equations. One with x plus 2 equal to negative 3, and then x plus 2 equal to positive 3. So here we subtract 2 from both sides. I have x equal to negative 5. Same here, subtract 2 from both sides. I'm going to have x equal to 1. All right, another problem where we're going to solve for x by completing the square. So this actually already has the cool, like the good setup that we look for. The x squared part, the x value, and everything else on the other side. Because I need these two pieces to start to complete the square. This number is just floating over on the other side of the equation. Okay, so we need to add that special number, b divided by 2 squared. Okay, so you go to x, the number on that is -2. So -2 divided by 2 and squared. And -1 squared is 1. So to complete the square with using these two terms, I need a 1 added at the end. And since it's this side is equal to that side, and I've added 1 over here, I need to add 1 over there. Okay, so from here to here, we will complete the square. And on this side, we have 3. Okay, and I like to draw a square. And then on one corner, x squared, the other corner, 1. And start to get the sides. X times x would be x squared. And use 1 times 1 to get 1. And this would be 1 times x, which is x. Here's another x. And you would add these terms together. So right now I've got x squared with 2x plus 1. But I'm trying to factor x squared minus 2x plus 1. So this needs to be a negative. This needs to be negative. So I would make that 1 right there negative, and this one's negative. Okay, so x minus 1 times x minus 1 is x squared minus 2x plus 1. So I can write this as x minus 1 squared. So this side to complete the square, and on this side I have 3. Now I can square root both sides. When I do that, I've got a plus or minus of the root of 3. And let's simplify this once, like for one more step, and then write our 2 equations. Okay, you got an x minus 1 on the left, and a plus or minus root 3 on the right. Actually, one way to do this is to keep this and then add 1 to both sides. And x equals 1 plus or minus root 3. So you have your two solutions. The x equal to 1 plus root 3, and there's an x equal to 1 minus root 3. Okay, so we're definitely gonna do one more. Check the time and see if we can. We'll do one more and then talk about functions. But if there's some extra time at the end, I'd like to do as much practice of solving with completing the square as we can. Okay, x squared minus 14x plus 36 equal to 0. This is the piece I want to use to complete the square. This number, you could leave it where it is. A lot of people would maybe put it on the other side. Either way, you'll reach the same two solutions. Okay. Let's just copy the problem. And I want to focus on these values, so I'm going to subtract 36 from each side. Okay, and then from here, to get from here to here, or to complete the square on this side, we want to add that special number. And to keep this equal to that, we add the number to both sides. Okay, what number is it? Okay, it's number with x, which would be negative 14. Negative 7 squared is 40. So I want x squared minus 14x plus 49. Equal to negative, that's a negative 36 plus 49. Okay, we'll figure out what this number is in a minute. And then first we're going to complete the square on this part over here. So let's start to complete the square, and I draw a square. Okay, so I'm looking over at this side. I want x squared in one corner and 49 in the other corner. piecing together the sides. X times x is x squared. 7 times 7 is 49. This would be a 7x and 7x, which we would add together. So you have 14x, but this part that I'm trying to factor is a negative 14x in it. So that I need a negative 7, with this being a negative 7. So I want x minus 7 times x minus 7. Okay, so x minus 7 squared is equal to x squared minus 14x plus 49. Okay, so from here to here, we have completed the square on one side. It's x minus 7 squared. All right, 49 with negative 36, it's going to be 13. And then we'll square root both sides with a plus or minus on the root of 13. Cool. All right, so that power 2 and that root 2 leaves the x minus 7. It's in the parentheses. Over here, 13 is a prime number, and we're just going to leave this root 13 like it is. But we can add 7 to both sides, and that way we've solved for x. So it's x equal to positive 7 plus or minus the root of 13. So your two solutions are 7 plus root 13, or 7 minus root 13. Okay, so we need to switch to talking about functions, which is kind of a whole nother topic. And then if there's some time left in class, we'll try to come back and do one more problem where you solve and you complete the square. But we're gonna jump into something different so that you can finish the last few problems of your homework. All right, we should have some time to do this. Okay, so we're gonna make it kind of simple and just stick with my favorite version of explaining a function, which there are many. And I like to say that for a function, it's a relation or relationship in which every input has one output. A function. Is a relation. Such that every input okay. Usually inputs are called X, otherwise you'll be kind of told what your inputs are for your variable. We're going to call inputs X. Function is relation such that every input x has exactly one output. Okay, and we're going to come back and we're going to give the function a name. Every function, this function we're going to call f. Is a relation such that every input x goes through your function f and has one output, which we call y. And sometimes we'll call f of x y. So note that f of x means the same thing as y. It kind of looks weird, but after quite a bit of practice, it starts to be more and more comfortable. I have a picture that might help. So we'll have your inputs and your outputs and your function that takes the inputs over to outputs, and every input has one output. Okay. So we're not going to go too far into functions, but technically the set of inputs is called the domain. And then your function takes those values over to the codomain, and the actual values that go through the function, that set is called the range. But right now we're just going to go with the codomain, and we're not even going to label it that. We're just going to say that's where your outputs are. Okay, so let's say over here you put in some number x. And you have a function that takes x over to one value y. That function's name, in this case, is f. So f sends x over to y, and sometimes we like to call y f of x. So it's f parenthesis x. Okay, let's start with an example. Let's let f be a function. Such that f of x, or f takes x to 2x minus 3. And we're going to have, you know what, we're going to stay here, one function. So first part, find f of 0. Just kind of notice that in place of x, you have a 0. So we're going to put a 0 right here for that value x. F of 0 is 2 times 0 minus 3. Which would be 0 minus 3 or negative 3. Okay, so that's the answer. But if you just want a bit of a visual of like just starting to see that a function takes an input to only one output, we're going to have a set of inputs over next to a set of outputs. and the function is f. And this time f takes 0 and sends it over to -3. Okay, this time we're going to put in x equals 1. Where does that go? If it's going through your function f, there's only one output. Find f of 1. F of 1. So if x is equal to 1, you have 2 times 1 minus 3. Or 2 minus 3, which is -1. It's positive 1, or f sends positive 1 to -1. And we can keep putting inputs into f and getting outputs over in this set once you've gone through that function right there. Okay, next problem, we're going to have two functions, f and g. Okay, f of x is going to be, f of x is 2x squared plus x minus 1. Okay, we're going to do this part. And we also want another function. G of x. It is 8x plus 7. Okay. First, find f of -1. Okay, so you're putting -1 in for x through the function f. So you need to put it into that function and replace this x and this x with the input -1. So I find it's helpful if every time you see an x, you put parentheses and then replace or inside parentheses, each time put that input inside. Okay, f of -1 would be sending -1 into that function. So you have a 2 times some input squared. The input is -1 plus this input of -1 minus 1. So again, I've heard it kind of explained like if you take each x value, put parentheses there, and then inside the parentheses, put your input. All right. -1 squared is 1. Minus 1. Minus 1. Okay. 2 minus 2. 0. Okay. part B, find g of -1. So you have x equal to -1, and it's going through the function g. So you need to pick this function and replace all x values with -1. Your function g, the input for x in this case is -1. So I have to multiply by -1. -8 with a +7 would be one more part to this problem is to get g of 1/2. So take the function g, and through that function, we're putting an input in of 1/2. And find the output after we replace this x value with that 1/2. Okay. Take the function g, send in 1/2 for x to get, I think it was, I'll check it, but it should be 8 times x, and x is 1/2. And then add 7. Okay. 8, which you could write as 8/1 if it kind of helps. So 8/2 is going to be 4. And you add 7. Okay, so I'm going to draw some pictures. First of all, from this first part, we had f of -1 equal to 0. We got g of -1, and it was -1. Okay, and then we put it 1/2 through the function g, or g of 1/2, and got 11. Okay, so since they're not the same function, they have 2 different pictures. There's an input, output, or domain and codomain for the function f, and there's another one for the function g. We're going to start with the function f. This is where we put values in. This is what we get out. And the function f, if it's a function, then every input has only one output, which we do have. We put in -1, and we got out 0. And then your other function g has its own set of inputs and outputs. Its own domain and range. Okay, g took -1 to -1, and it also would send 1/2 over to +11. And then same for other inputs, would go to certain outputs depending on the function. Okay, let's see if there's any time to do anything else. Nope, I've already kept you over. I'm sorry. All right, that's the end. Thank you for staying a couple minutes late. and have a happy holiday.